Good afternoon, everyone. It's my honor to be here today. My name is Xiaoxuan Zhou. I'm a master's student from Zhejiang University, China. Today, my presentation topic is guiding visual attention in remote operation, meaning task and object in post-disaster scenarios. Research shows that frequent human activities have deteriorated the natural environment, increasing the frequency and intensity of extreme weather and natural disasters. Global emergency management systems are facing unprecedented challenges. Using drones and robots for remote search and rescue allows timely access to disaster sites, where they gather information and even conduct rescues. This method is especially effective in confined or hazardous conditions. Due to the complexity and openness of these tasks, current research and rescue robots lack sufficient autonomy and require human pilots. Human operational data is essential for machine learning and training. Pilots must view live feeds, quickly gather and record information, and make real-time decisions. Their efficiency relies on how well they allocate visual attention under complex, urgent, and high-stress conditions. How is visual attention prioritized to allocate resources? Many studies suggest that attention is unconsciously drawn to areas with bottom-up features like brightness, color, or orientation, etc. However, attention is also guided by top-down cognitive features such as meaning, which are harder to quantify, leaving a research gap. These studies often use static images and focus on simple, everyday things, overlooking the complexities, time constraints, and special tasks of real-life scenarios. Against this background, we designed an eye-tracking experiment based on a real search and rescue task. We contrast a two-story indoor building model of post-earthquake scene. Based on the meaning of the task, various objects within the model were categorized into three types as basic areas of interests: their danger, information, and environment. During the experiment, participants navigated a predetermined route through the model at a varying speeds. At specific moments, the scene would freeze, asking participants to make further decisions. There are a total 30 search points, and we quantified these scenes further. First, from a cognitive perspective, we employed the meaning map method, creating pixel-based meaning maps of the scenes by segmenting and scoring them. To further explore the impact of search and rescue tasks as high-level features, we quantified this aspect separately through attribute maps. After semantic segmentation of the scenes, each attribute was mapped individually, reflecting the relevance of object to the task. We also considered the impact of low-level features using classical graph-based visual saliency model to create visual saliency maps for the 30 scenes. We then explored these factors statistically. Initial studies suggest that while meaning and saliency represent different factors, they are correlated. Our analysis shows this relationship still holds in post-disaster scenes. When considering the impact of meaning on visual attention, it is necessary also to consider visual saliency. Our results show that both are correlated with attention, with meaning accounted for 12% of the variance in attention, while saliency accounts for 6%. To demonstrate their independent effect on attention, we calculate the semi-partial correlations between them and attention. The results indicate that meaning independently explains 10% of the variance in attention, double the explanatory power of saliency. Further, we consider task-object features. We examined the relationship between attribute maps and attention, finding that each attribute subtly influenced the portion of attention. The correlation between the attribute of danger and meaning was negatively correlated, indicating that post-disaster scene or damaged or disordered objects impact cognitive processing. make recognition or analysis more difficult, and reducing meaning. This highlights the distinctiveness of such things. Here, we summarize the main conclusions which have been detailed in the preceding sections. Based on this research, several issues need further exploration. First, in this scenario, the impact of 5 factors on attention is weaker than in everyday things, suggesting that additional undiscovered factors may influence attention. Secondly, while we included dynamics in this experiment, the analysis remains inadequate and will be a focus in future work. Additionally, short-term memory and cues are significant in continuous things. Lastly, we aim to propose practical solutions to enhance search and rescue efforts based on our research. In conclusion, our findings not only provide data support for application of remote operation, but also deepens our understanding of how visual attention functions in complex real-world scenes. I appreciate your attention, and I'm grateful for the opportunity to share my insights today. Thank you.
Thank you very much for your